All right, so we want to take a look at acceleration here. And as it says above, acceleration is a change in the velocity of an object. And because velocity is a vector, if we're going to change that, we have to also have a vector here. So acceleration is a vector. Remember, it requires a direction, positive or negative, north or south. A lot of times, and I didn't mention in the last video, a lot of times we like to take some sort of physical quantity or physical direction like north or south, up or down, and actually give it a positive or a negative in order to do math with it. And it doesn't matter what you pick as your positive direction as long as you're consistent. So if it makes more sense for a problem to say, you know what, south is going to be positive this time, you can totally do that as long as south is always positive for that problem. So here with acceleration, this direction really matters. So positive acceleration means your velocity is getting sort of more positive, or a bigger magnitude in the positive direction. And if you look above to that chart, this is where people get confused a lot of the times. A lot of times they say, oh, a positive acceleration, that must mean that it is increasing in speed, it's getting faster. It doesn't mean speeding up. It just means that the velocity is changing towards the positive direction. If you're already moving in the negative direction, you're going to start slowing down. You're going to get a change that is towards the positive, so it's kind of like it's pulling you back. It's changing that speed in the opposite direction that you're already going. So it does not necessarily mean that it is speeding up if it is a positive acceleration. So let's say you're a person right here, and you're walking with some velocity, let's say it's 10 meters per second we'll say you're going in the negative direction here. And let's say that we had an acceleration that was in the positive direction. So because I made to the right negative, if I want a positive acceleration, that's in the opposite direction. So if I'm being accelerated this way, think of it like if someone was pushing you in that direction of that acceleration. You're going to be slowed down. If I'm moving at 10 meters per second to the right and someone pushes me to the left, that means I'm going to slow down. So in this case, because these two signs do not match, I am slowing down. So let's do a little calculation with this. This is sort of a shorter unit, but this not unit, sort of topic, but this idea right here, this idea of a positive acceleration not necessarily meaning you're speeding up is big. If it's not making sense to you, memorize that chart. Get used to that idea that this acceleration, that direction, doesn't necessarily mean slowing down or speeding up. You have to compare the direction of the velocity and the acceleration. So let's say we had, for example, a car. A little car, it kind of looks like a baseball helmet, but that's okay. And let's say it was initially going 25 meters per second, but it's coming up to a red light. So when it gets there, because it follows the law, this car, it is now going 0 meters per second. And my question for you, or for us, is what's my acceleration? If this process, if when he started to hit the brakes here, to here, let's say he slowed down in 2.7 seconds. So I go to the equation of my acceleration. Acceleration is a change in velocity, a delta V, over the amount of time. And before I even go into this problem, I've got a positive acceleration I made to the right positive here. I'm sorry, not a positive acceleration, a positive velocity. And then I've got this zero velocity. So I know that I slowed down. My speed, my magnitude of my velocity went from 25 to 0. So I slowed down, which means that my velocity if it was positive to start with, my initial velocity was positive, that means that my acceleration is going to be negative if I do this problem right, because in order to slow down, I have to mismatch those two signs. So I'm going to go back here, my acceleration, my change in velocity is the same as my final velocity minus my initial velocity, divided by the amount of time it took. So I'm going to substitute in my numbers. My final velocity was 0, minus 25, over 2.7. So I've got negative 25. And it's hard to do negatives on these calculators, so I'm going to just do it as a positive and then change it to a negative afterwards, divided by 2.7, which means that my acceleration was 9.26 meters per second squared in the negative direction. And that's it. And my signs matched up. This number was negative. If I divide this negative number by a positive number, I should get a negative answer. That checks out with sort of the logic that I put through at the beginning. I said, I know that this should be a negative number. If I do my math right, it will come out a negative number, and it in fact did.